Now it's about time to see how all the technology we have just described come together and help us to build the most responsive application on the planet. For this, we have built an e-commerce application called RedisMart that relies 100% on Redis. Deployed and run across multiple clouds using active-active Redis technology, RedisMart leverages the combination of JSON and search. To demonstrate the application, I am welcoming Ash Sahu, Director of Product Marketing, to show you how it feels when your e-commerce application executes every operation in real time. Ash, over to you.
Thanks, Iftak. I'm Ash. I'm going to demo how you can use RedisJSON with RedisSearch to build real-time applications with interactive search experiences. So as Iftak mentioned, we've actually created a fictitious retailer called RedisMart that sells electronics, appliances, and other items. It's actually a fully functional e-commerce store built entirely on Redis. So I'm going to I'm actually looking to buy a movie to watch with my son. So either I can click on the category or I can go to the search bar and search for movies. In fact, 30% of shoppers use the search bar to find what they're looking for. So the search has to be fast but also typo resistant. Let's talk a little bit about speed. I'm going to open this console and look at the performance. This page is dynamically constructed using data coming through an API from the server. What I'm trying to do is narrow down my search using this faceted navigation on the left-hand side. I'm going to make it a little bit more reasonably priced. I want a higher rated movie, and I'm going to narrow it down to just movies and TV shows. Well, if you see the number, keep an eye on the number on the right-hand side, you'll see that it's less than 100 milliseconds. This is the time to first byte, which means that complete end-to-end latency. Below 100 milliseconds is actually blazing fast. And you may wonder what's the big deal about 100 milliseconds versus 1 second. In fact, research has shown that if the performance slows down from 100 milliseconds to 400 milliseconds, then it has measurable impact on users. Now, as more and more users and businesses are going online, a faster performance means a better online shopping, a better digital banking, a better telehealth experience, which leads to more usage and more satisfied users. The speed really matters. I'm going to close this now, and we're going to go behind the scenes to see what's happening on Redis. First thing I want to show you is the JSON document which is sent back. Now, JSON is the lingua franca of the internet. 80% of modern applications use JSON as data format, mainly because it's flexible, it's intuitive, it's used in the application layer, so it's very developer friendly. Now, RedisJSON supports store and query rich nested JSON documents. It also supports atomic operations on this nested documents, so you don't have to load processes in the application layer and reload things again. Let's look at what the search query really did. So FT search is powered really is by RedisSearch, and RedisSearch is our secondary index and full text search engine for hashes. And as Iftak and Peter just announced, we also support JSON documents now. This means that you can run exact text, fuzzy search, prefix phonetic stemming, and a bunch of other full text search functions using this one unified API that's purpose built for performance. In fact, it also rapidly indexes frequently changing data sets, so you never have to return back stale data. Below that is the FT aggregate command, which allows you to run simple analytics. And in this case, you're actually constructing those filters dynamically from that aggregation of all the items coming back thanks to that search. So Redis JSON and with RedisSearch is really a game changer. It brings millisecond latencies, even during seasonal peaks like Black Friday and Cyber Monday. Now I'm going to find what I'm looking for finally. So here is here's a safari. We just got back from safari. My kid's into wildlife. This will be interesting for him to watch. I'm going to add it to the cart. I'm also going to look for headphones so I can work while we're watching the movie. I'm going to highly rated headphones, a little bit more higher end. This black one looks great. I'm going to add it to my cart. I'm going to check it out. Now you can see this local pickup. So RedisMart supports buying online and picking up curbside or at the store. And this lookup is powered by RedisSearch. In fact, you can use RedisSearch not just for searching by text or numeric filters, but also do geospatial searches so you can find the stores closest to you. So that's because of RedisSearch. Now I'm going to shift gears a little bit before I place the order because I want to talk to you a little bit about how RedisMart was deployed and give you a retailer's point of view. So RedisMart is deployed across 3 different geographical areas. One is in US Central on Google Cloud. The other one is on US East on AWS. And the last one is on Azure in Northern Europe. I'm actually opened the inventory page for Redis for the Azure location because I want to show you how you can how data is being synchronized using active technology. So let's go and split screen this, and I'm going to pull it up, and I want you to keep an eye on the amount on this speakers which are in of these headphones which were in my shopping cart. And as soon as I place the order, you can see that amount got reduced in stock from 65 to 64. Now that happened almost instantaneously. These 2 data centers with the application and the database are almost 5,000 miles apart. So Active allowed you to synchronize data across different geographical areas, but also across different cloud providers. Now you may be wondering, hey, what's this seems like a small feature. Actually, this is quite a big deal. This enables retailers to implement real-time inventory management, so they can get more accurate view of their inventory or avoid stockouts. You can do inventory optimization, so they can actually fulfill orders from nearby stores. This was not possible before because their existing backend systems are not really built for the real-time era, and they're slow, and all processing happens in a batch process. Well, this wraps up my demo. I want to just summarize by saying that RedisJSON with RedisSearch can help you build real-time applications, power real-time search, and get real results. All right, back to you, Iftak. Thanks so much. Bye.
Very impressive, Hash. Thank you. Now let's assume that you want to enrich your application with some AI capabilities. And in the context of an e-commerce application like RedisMart, you want to add a visual search, the number 1 desired feature by e-commerce customers. Normally, this would require introducing an all-new technology stack. But it turned out you can do it with Redis too, and maintain the real-time experience we are aiming for. Before getting to all the details, what is running behind the scene, let's first get back to Ash to show us that this can actually work in real application. Ash, please.
Thanks, Iftak. Well, we're back for one more thing. It'll be quick. I'm going to show you how visual search works on RedisMart. So I'm going to click the camera button. It'll open up the webcam on my computer, and I'm going to try to look for these headphones. So I'm going to scroll up and click capture. Well, you can see the similarity search returned back 4 results. In fact, the first one is actually a headphone similar to mine. So it's done a good job of identifying my headphone and finding similar ones in the product catalog. The other one's also not bad. They have similar contours at the headphone. So now back to Iftak to explain how RedisAI works and how it seamlessly integrates into your Redis technology stack. So back to you, Iftak.
Thanks again, Ash. So how does visual search works? In essence, it's powered by a few technologies. These include RedisJSON and RedisSearch, which we have already mentioned today. But in addition, there is RedisGears, our server-side execution framework or programmability engine, and RedisAI, which brings real-time inferencing to Redis. Here is how it works. Every image is translated to a vector. These vectors are stored in JSON and indexed by RediSearch. Under the hood in Redis, the client calls RedisGears functions with a reference to an image. Gear passes the image to RedisAI, which translates it to a vector. Gears then call RediSearch with the image vector. RediSearch performs a similarity search and returns the URL for the images that are nearby in the vector space. Let's take a closer look how long it takes to execute this flow. The inferencing phase, in which RedisAI translates an image to a vector, takes around 300 microseconds. Our vector similarity search algorithms works in a near constant time of no more than 500 microseconds, even with a collection of millions of images. And finally, the gears functions overhead is around just 100 microseconds. This brings us to a total processing time of 900 microseconds, so we are still under the millisecond. And this is how powerful Redis is for real-time AI use cases. Even after adding some non-trivial AI functionality to the stack, the processing time didn't go beyond a single millisecond.